Now we are at question 2 in tutorial sheet 3, and this question says that the long-run total cost function for a firm producing skateboards is given by total cost is equal to q cubed minus 40q squared plus 430q, where q is the number of skateboards per week. Part A says, what is the general shape of this total cost function? Well, the general shape of this function is a cubic cost function, but don't worry, we will not ask you to sketch a cubic cost function. So part B says, calculate the average cost function for skateboards. What shape does the graph of this function have? At what level of skateboard output does average cost reach a minimum? And what is the average cost at this level of output? So there's a lot of things in part B alone. So let's start with the first part. Calculate the average cost function for skateboards. So we know that the total cost function is given by q cubed minus 40q squared plus 430q. So the average cost function is equal to the total cost function divided by q. So if we type back the total cost function, q cubed minus 40q squared plus 430q, and we divide the whole thing by q, so then this would cancel out with this would turn to 1 and this would turn to 2. Then we would have the average cost function equivalent to q squared minus 40q plus 430. So that answers the first part of part B. Now the second part says, what shape does this graph of this function have? Well, it will have a parabola shape. It would have a parabola cost curve. The next part of this question says, at what level of skateboard output does average cost reach a minimum? To calculate when it reaches a minimum, we need to take the differential of the average cost and set it equal to 0. And then we need to take the second differential and see if it is indeed a minimum or a maximum. So let's take the differential. dq of the average cost would be 2q minus 40. So that equal to 0. Then we'll have 2q minus 40 equal to 0. Therefore, 2q is equal to 40. Therefore, we can say q is equal to 20. But we don't know if q equal to 20 is the minimum as yet. We need to take the differential of this. So essentially, the second differential of the average cost to know if this is indeed a minimum. So let's see. If we take the differential of this equation right here, then it will just equal to 2. And since 2 is greater than 0, then it means that the average cost curve is indeed a minimum. Therefore, 20 at q is equal to 20, the output of 20 will give you the minimum average cost for skateboards. So the next part of the question says, what is the average cost at this level of output? So to get the average cost of that level of output, we just need to substitute 20 into this equation right here. So I guess we can just do it right here. At q equal to 20, the average cost would equal to 20 squared minus 40 times 20 plus 430. And if you calculate all of this, you should get an average cost of $30. So $30 is the minimum average cost that you can get. Now that answers part B. So part C says the marginal cost function for skateboards is given by MC equal 3q squared minus 8aq plus 430. Show that this marginal cost curve intersects the average cost curve at its minimum value. So we know the minimum point for the average cost is at q equal 20 and the average cost equal 30. So we need to see if at q equal to 20, which is the minimum cost of the average curve, if at that point the marginal cost is also equal to 30. If it is, it means that it would intersect the average cost curve at that point. So let's see. The marginal cost curve is given by 3q squared minus 80q plus 430. At q equal to 20, the marginal cost curve is equal to 3 times 20 squared minus 80 times 20 plus 430. And if you calculate this, you should get a value of $30. So therefore, the marginal cost curve is equal to $30, which is equal to the average cost curve at when q is equal to 20. Therefore, given what we know about the average cost curve so far, if we was to sketch the average cost curve, q average cost, it should look something like this, where the minimum point would be when q is equal to 20 and when the average cost is equal to 30. And so we know the marginal cost must also pass through this one point here. Since the last part asks us to graph both the average cost curve and the marginal cost curve, we need to know one more information about the marginal cost curve. Does it cut the x-axis, and if it does, at which point? We need to calculate if it is a minimum, and if it is, we need to see at which point on the x-axis it cuts. So let's see if the marginal cost curve is a minimum. We need to take the differential and set it equal to 0. dq of the marginal cost curve. So this is equal to 6q minus 80. And we need to set equal to 0, set that equal to 0. And so 6q minus 80 equal to 0 would mean that 6q is equal to 80. Therefore, q is equal to 13 and a third. Now, we don't know if this is the minimum point as yet, unless we take the second differential. So I'm just going to take the second differential in this top corner right here. So we're taking the differential of this equation now with respect to q. And so that would just equal to 6. And since 6 is greater than 0, therefore it means that the marginal cost curve is indeed a minimum curve. So now we know that it also takes that U-shape form. And we also know that q equals 13 is its minimum point, but we don't know the marginal cost value at that point. So let's calculate that. The marginal cost curve would be 3 times 13 and a third squared minus 80 times 13 and a third plus 430. Right, so if you was to calculate this value here, you should get negative 103 and a third. And so if you look at the small graph right here, we know that the minimum quantity for the marginal cost curve, the quantity where marginal cost curve would be a minimum, is at q equals 13 and a third. And at that value, the marginal cost would be negative 103 and a third. Therefore, negative 103 and a third is the minimum marginal cost they could get. However, marginal cost would never really be negative. So we would draw it from this point here where the graph is positive. And to get these values here, where it cuts the x-axis, then we need to set marginal cost equal to 0, because at those 2 points is when marginal cost equal to 0. There's an easy way to do so. We can just use the quadratic formula, because the quadratic formula would give us the roots of any quadratic equation. So the quadratic formula says x, well in this case it's q, is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. And if we were to enter those values, it would be negative minus 80, because b is minus 80, plus or minus the square root of negative 80 squared minus 4 times 3, and c is, I believe, is 430, and divide that whole thing by 2 times 3. And when you calculate that, you would get two values, one for when it's a plus and one for when it's a minus. And those two values should be 7.46 and 19.20. So therefore this value here would be 7.46, and this value here should be 19.20. If we were to draw a graph now based on all the information that we have, so if you were to draw a graph, q average cost, marginal cost curve, we know that the average cost curve is a parabola where the minimum point, and excuse my bad drawing, but the minimum point here, we know q is equal to 20 at this minimum point, and the average cost was equal to 30. And now we know the marginal cost curve somewhere should be somewhere here coming up. This is the marginal cost curve, cuts the x-axis here at 19.20. If you want a neater drawing, then you could use this. We know this value here is 19.20. So that was the only thing missing from this graph. So that's it for this question. Thank you for watching, and I'll see you in the next one. Goodbye.